Is it on? I have no idea. I can't see when I'm.
Yeah, Chris, can you request the captioning thing? I don't see it on my Mac. All right, you're good to start.
Okay. Hello, this is the beginning farmer asset mapping project, and today we're going to present all of the hard work that our DSPG team has worked on over the summer. And so I'll continue on ahead. My name is Harun Çelik. I'm the graduate fellow for this project. Alongside me today, Sonika, Nabil, and Corey will be presenting their portions of the project. And of course, our project lead, Bailey Hansen, is here. So at the end, when we have questions, we can all chime in and try to answer any of those. So just to give a sort of map of what we're going to talk about today. First, I'll mention very briefly the data sources that we selected for the project. We've had to do a little bit of exploring in the beginning, and the project was sort of open-ended, which was a good thing for us in terms of exploring, but also it did demand that we had to go and find things ourselves a little bit. So I'll mention those, and then each of the interns will also talk about what they use for their respective sections. And so the first first section will be Sonika's, and she'll talk about the specialty crop data. She'll talk about sort of the initial findings and the sources, how we thought about which crops we would want to use and what not to use, then how this all fit into this idea of visualizing the growing degree days in our dashboards and calculating those values too. And then finally, in basically taking professional advice from extensions and other sort of agricultural handbooks and trying to put that into our dashboards so that we could give that advice and serve as a little bit of the middleman here, since we're not agricultural experts or horticulturalist experts. Then Nabil will continue and he'll talk about the weather data section. He's going to talk about the data discovery. You know, we look at our phones and we can find weather data pretty accessible. It turns out that when you need weather data for a project, it isn't that easy. So he'll talk about how what we had to go through to find that data, to be able to pull that data, and that's what the extracting weather information is about. And it's not just, for example, precipitation, but we try to get heat and wind and other sorts of variables. And finally, he'll talk about the risk management section, which is climatic variables, which obviously beginning farmers are interested in order to make decisions about which crops and land and area they want to use. Finally, Corey will talk about the soil data. Specifically, he'll be talking about the Surgo data set. And this is a massive data set about the, it's basically a web soil survey, but a huge data set. And because of its size, we had to figure out ways to obtain this data in ways that could be reproducible in the future, and not just have to store all that information. And he'll talk about how he combined that soil information along with the crop information that Sonika had created in her data frames. And finally, the making of the Tableau section is all about how we brought all that information together into one accessible interactive dashboard, how we made the visualizations dynamic, how we attempted in making a website for user inputs, and eventually we'll show a demonstration of our dashboard. And the flow charts are just to give an idea about how the current operation, the order of operations work for our code now, and what we think would be the best future implementations of the project. So I'll just jump right into the data sources now. The first, there we are. The first of the sources was the Iowa Environmental Mesonet Reanalysis tool. This is a tool that I should say Daryl, but Daryl from the Iowa Mesonet website recommended us for pulling climate information, and it really helps to bypass a lot of problems associated with single site observations for weather data that Nabil will talk about. And from this tool, we receive our precipitation, temperature, all sorts of data, and Nabil will go into more detail about what it is exactly we receive and what we format. The second is the Soil Survey Geographic Database. This is a database that is created by the National Cooperative Soil Survey, and it covers about 95% of the US and the county's soil map units. And that's what you'll be seeing when we demonstrate our dashboard. This is a massive data set, and Corey had to do a lot of work at figuring out which parts of the data set we need, what we need to extract, what can remain sort of unpulled, etc. And finally, Sonika will talk a little bit more about this, but we settled on two primary sources for our specialty crop information. The first is a Iowa State Horticulture Extension. It was provided by them, the Midwest Vegetable Production Guide. And the second was a recommendation by some of the horticulturalists we reached out to on Nat's Handbook for Vegetable Growers. So Sonika can take it away and start discussing that information now.
All right, hi everyone, I am Sonika, and basically this is just an overview of everything that I looked into. One of the primary things would be building of the specialty crop dataset, as that worked as a foundation to build on a lot of other things in the project, like the growing degree days, crop rotations, and so on. So I'll be covering the insights on the sources that I referred to and the challenges that I faced, followed by the growing degree days, what they are and how I calculated them, and last, just an example of crop rotation and what that is. So some of the initial findings would be building of the specialty crop dataset. It includes 19 specialty crops and information about them, such as the soil types, pH levels, the rooting depths, storage conditions, crop maturity, soil nutrients, etc. So there was a lot of data scraping that went behind the building of the specialty crop dataset. And as Harun mentioned, some of the primary sources were the 2022 Midwest Wedge Guide and the Knott's Handbook for Vegetable Growers. Some of the commonly faced hurdles would be data insufficiency. And again, since we're not experts, it was hard to know if the information was misleading or incorrect. A lot of times the information was very generalized and not area specific. But nevertheless, we managed to build the data set, and here's just a snippet of the specialty crop data set, 19 crops with like information about all of them. Yeah, so this is kind of what it looks like. Moving on, so what is GDD? So growing degree days are basically used to estimate the growth and developments of plants during the growing season. So usually how growing degree days work is by calculating the accumulated growing degree days for a month and comparing that to the past years to see the trend of the growth. A lot of times they are compared to the last 30 years. So how growing degree days are calculated are by subtracting the base temperature of every crop to the average temperature of each day. So what base temperature is basically the minimum temperature about which the growth of the crop starts. So every crop has a different base temperature. So like lettuce, asparagus, oats, they have a base temperature of 40 Fahrenheit, whereas sweet corn, soybeans, tomatoes, they have a base temperature of 50 Fahrenheit. If the average temperature of that day is lesser than the base temperature, then there is no growth, and then the growing degree day is 0. So here's just a snippet of the calculation of GDD, and how I calculated that was by combining the Iowa State Mesonet climate data to the base temperatures of the 19 crops. And the climate data that we looked at is from 2015 to 2021. So yeah, we focused on the months from April to October, since those are the ones that have a suitable temperature for the growth of crops, because other months are winter. So here's just a snippet, a visualization of the growing degree days. Here, I've shown the crop carrot, but users have the flexibility to pick any month from the filter area and whatever crop out of the 19 specialty crops, and see the trend of how they have grown over the past years, again, from April to October. So this is kind of what it looks like now. Moving on to crop rotation. So crop rotation is the process of growing crops on the same land over and over again in a sequence. So crop rotation helps in the improvements of chemical, physical, and nutritional properties of the soil, and is beneficial to the crop system as it reduces weeds, insects, and plant diseases. So crop rotation is one of the best farming practices, and these examples are a good resource for beginner farmers to incorporate crop rotations. Here's just an example of how one may integrate crop rotations. So users can select the crop, and the information about the specialty crop will determine which cover crop to use in the rotation, and when it needs to be terminated will pull up on the side. So here we can see example 1, but we have 5 different examples. So that is pretty much what I've been working on.
Thank you, Sonika. We will also explore this more on the dashboard later, so just wait for that. Next, Nabil can talk about his weather data section.
Hi, I'm Nabil. So I was tasked with looking into weather data, because climate change as well as extreme events like drought, floods, and storms have an impact on productivity of farms. So I'll go through the data discovery process, some of the sources and challenges, and how to extract the weather information, and the risk management side of things, what resources are available. And for the data discovery process, so the objective was trying to find data for locations by latitude and longitude. And the data is available for stations, but not always for certain areas. And I've looked at some examples are NOAA, the Applied Climate Information System, ACIS, and the National Weather Service. So for example, in the photos here is the climate data online data set. So they have all these information, daily summaries, global marine data, global summary, but they are specific to a certain station. So we had trouble trying to find the information for areas between those stations. And that's where the Iowa Mesonet comes in. So the environmental Mesonet reanalysis is a tool that collects environmental data, and the data includes wind speed, wind direction, precipitation, and temperature. And they have access to hourly and daily intervals. So the data can be accessed through some JSON web services, and they have a multi-day, single-day request, and single-day hourly. And we were able to pull information by latitude and longitude. So here the code, the script here extracts the weather information. So it builds the URL from Iowa State, the Mesonet site. And as you can see, there's a latitude and longitude that is the input. And then we can set the dates. It only does, it doesn't do multi-year. So you would have to do in the same year. And it would just loop through that and get all the information we need. And then after having a discussion with the Mesonet developer, Daryl, he recommended we use the Prism. And also Prism is the official data for the USDA. And then we also use the daily values of the high, low temperatures, and then the precipitation. Next, so here is I built off the base script to include a script for date input. So on the left, we'll create a list of dates that users can select. So in this case, it would be April to October, and they can select which dates they want, and those dates will then be put into the script, and they will be able to update for that particular date range and location, and it will be saved and passed on to a script that will aggregate the weather data. So here is the risk management resources. So we thought it was important to include this because extreme weather such as droughts, floods, and heat waves can affect crop yields, livestock health, and due to climate change. And then the first tool here is the hazard index map. It is a national risk index that aims to help users understand their communities, which is at most risk for natural hazards, including drought. So here you can put in the location. Go back one more. Put in the location, and it'll tell you, the table shows you how they calculate the national risk index. Next. So here is the national flood hazard layer. So this map will show users the community and how floods can affect that area. And you'll be able to download a flood insurance rate map that will show you the information you need. And finally is the US drought monitor. So this map will show you parts of the US that are in drought, and it will give you the statistics. So based on the location you choose, for example, we chose Boone County, you can choose yours, and it will highlight the black box right there. And it will show you the statistics and the historical drought data related to it.
Now we can talk about the soil data. Go ahead, Corey.
Hello, I'm Corey. I'll be the one talking about the soil data. What you'll hear from me is about our initial findings about how soil relates to crop growth, the data set we used to obtain soil data, as well as how we used R to gather both the soil data and combine it with that crop information to produce suitability. So one of the first things we looked at was trying to figure out, is there some soil data set out there that we can use? And we came upon two different ones, the Surgo data set and the StatsGo data set. The StatsGo is another nationally soil data set in the US. However, we chose to go with the Surgo data set just due to the fact that it's more variant for smaller areas, as well as the fact that for the StatsGo, the underlying data in that is Surgo, so we're going to use that data set anyways. Another thing we chose to look into is what soil factors are going to affect crop growth. And just to list a couple of them were pH, soil texture, organic matter, nutrient level, and there's more, and we'll talk on those a little later, but we just want to share a little of them we found. On the top right, you're going to see a triangle, and that's a way to find the soil texture of a specific soil, which will have a percent clay, percent silt, and a percent sand with it. And you use that triangle to determine what soil texture it is. And then below that is just a list of nutrients that are important to crop growth. Speaking of the data set that we used, we're obtaining this from the USDA Web Soil Survey. There's already a website that allows users to select some area and get just soil data. And so the plan was to use this download to obtain our soil data and use it with our crop information. And before I go any further, I'll talk about the data set itself because it's a little interesting. And it's not just how you normally think about it. It's split into three main parts for the soil. There's a part you're going to see the map units. It's what when we show you this on a graph, that's what you're seeing is the map units. But a map unit is comprised of these components, whereas it might be 80% of one component and 20% of the other component. And those are going to differ based off soil texture and maybe some erosion factors. And then for each component, they're going to, when they collect data, they take data at different levels. So they might take it at 5 inches deep, 10 inches deep, and then like 20 inches deep. So each of those gets assigned to a specific horizon value. And so for a specific component, there might be anywhere from like 5 to 15 different horizon values. And so if we go to the next slide, how we used R to obtain and clean this data, we didn't want to be stuck downloading large files like county-wide files or have the user manually download the files themselves. So we're using a fed data package to download circuit data for a given area. Some of the data cleaning we had to do with this is we converted the centimeters to inches. And then for those differing depths, we took the values that were given, we took the average values dependent upon the crop's maximum rooting depth. And then we also selected surface level qualitative values like the soil texture to keep consistent with other resources that use the same data set. So I'll talk initially about one of our beginning ideas of how to show suitability. We first linked the soil data to crop data by finding if the soil pH was within the range of a crop suitable pH range. And then we colored it based off of the word share of soil texture. However, we wanted to include more factors to consider than that. And just looking at 2 factors wasn't going to be just good enough for us to show suitability. So we looked deeper into what other factors can be considered. And we looked into the factors that affect the corn suitability rating. And some of those factors are erosion tolerance and type, flooding frequency, water drainage and water storage, as well as nutrient levels. One of the specific nutrients we want to find information of was nitrogen. However, we were not successful in finding any sources for nitrogen levels in soil, just due to the sheer variability of nitrogen. However, we found an extension on the Colorado State that gives us soil recommendation values. So with that in mind, we redesigned how we thought about suitability, and I'll briefly walk through you how we determine suitability. It's based on the amount of issues between crop and soil. So what I mean by that is, let's say a soil has a specific average pH. If it's not within the range of the crop's suitable pH, it's going to increase the number of issues because that is something you would want to have changed when growing that crop. So that the more issues a certain piece of land would have, the more flags it would have, and it'd be harder for you to actually grow that crop in that area. And just as of now, we weight every issue the same, but we are aware that some issues like soil texture are harder to change than pH.
And this was and thank you, Corey. This was something that we learned along the way as we spoke with Krista in our client meetings. So I'll briefly talk about how all of this information is now merged together. So we had Sonica working on the data frame for the specialty crops, Nabil on the weather data, and Corey on the soil. And we wanted to bring all this information into one interactive dashboard that the beginning farmer can use to see very clearly. And we decided to go with Tableau because we had already sort of visualized the map units on that software. We decided to split the tabs to separate information so that we remove sort of the clutter and that the user experience would be a little bit better. So as we'll demonstrate later, we have a rotations, crops, soil, weather, risk links, and a GDD section that the user can select. And all of this is joined together, and that's what this image in the bottom is trying to show. All of the information of the specialty crops is merging together with weather and soil data, and it's all working together to make a lot of the visualizations dynamic, so that when you do select your area, we can calculate a centroid point, which will then give us the county, and we can, when you look over at your risk management section, you would be able to see the drought information for your county. You'd be able to look at flood information for your county. And we have tested this and we have tested it and found out that it doesn't work just in Iowa, but also in different parts of the US. So that dynamic element is important for this reason. We've also tried to connect a lot of that information to a web interface. And what this interface tries to do is the user can select an area on their map, choosing between satellite and street map images. And once they've selected their area, they just have to pick the year for weather and the months, starting months and ending months. And Sonica and Nabil had both mentioned this, but the user might want to just check out what May to whatever month is like, and not include winter. So there's that option for them. When we submit, what's supposed to happen is our PHP code is working alongside our R code. So basically our two scripts are working together to take that user information and to put it into our Tableau. Currently that information, that process is local and manual, and Nabil will talk more about that, but we can try and now to demonstrate what the user input would look like for the time being. Corey, would you like to share your screen for that?
Yes, I can. Do we see my screen? So this is that same image that was shown earlier. We have outline, it's in the hybrid mode, so you can see the satellite image. We can then zoom in to a specific area that we want to get the data from, let's say like this. When we select a year for weather, we're already calculating from the current date. So if we want maybe like 5 years of weather data, we can go back to 2017. And then we want the range for, like, as I said, maybe like an April through October, right? We don't really care about the other month. And then once we press submit, all that information gets sent and the R scripts start running. Currently, this takes about 2 minutes to complete. So we'll talk about what's actually happening in the background as this is going on.
Nabil will continue to explain a lot of that process with the code now.
So the first starting point is the select an area on leaflet, and then the user can find the coordinates of the bounding box. So another process is going to run to calculate the centroid of the bounding box that helps determine the latitude and longitude, which will be used in the ISU Mesonet. So it will take the user inputs locally, and then they can select year, the month, and then the end of the month. Excellent.
Did it not work with the screen share? There we
Okay,
go.
okay. So it will connect to PHP, and then these will run separately. They'll pass the user input parameter to an R script, which connects to the weather data, and they'll calculate the GDD and aggregate the weather data and connect to the Surgo soil data, and they will merge with the crop data set. And all of these will be saved as a CSV file locally. And we have to do a manual refresh to connect the data to Tableau, and then extract the files to publish it on Tableau Public. Yeah. So this is the future implementation of the workflow that we talked about implementing down the road. So the process starts the same. You select the location and the rate range, and then take the user input. So since the current workflow is the files are saved locally, we would ideally like to consolidate these files into one location. And then we would add, when taking the user input, we'll create a unique user ID. And this will be added to the CSV file to store the IDs, and then the process to connect to PHP, and then pass the parameters into the R script. Yeah, so the process after calculating the centroid, we would run these processes together versus separately to connect the soil data, connect weather data, and then running the GDD and aggregated weather data together versus running them individually. And then you can weigh the flags by how hard they are to change. And after saving the scripts, we would add a script to clean up the IDs and remove some of the data that's been collected after some amount of time. And then the output would be saved to a server that would update Tableau in real time versus manually refreshing it.
Right. And now we can show a demonstration of the dashboard as the current workflow. And I'll share the same link with everyone in the chat now. Can people see my screen here?
It just went away.
It went away. Okay, 1 second. Let me. How about now?
There we go. Yep.
So this is a live web page. I'll put the link in the chat, and anyone who likes can follow along. I'll just briefly go over the main page and what sort of options there are for navigation. So we only have the one dashboard, and this is the dashboard that would appear once all of the files are locally refreshed and manually updated. And the dashboard development section is all about documenting the work that we've been doing and coding, so that a lot of this is reproducible, or if people have questions about how we figured out certain values, this would be documented here. So, and this is available for each of the sections that we've explained today, starting from the soil data to the specialty crop information, the weather information, and then that user input section that we talked about at the very end. So we now have a demonstration of the dashboard. Because the current workflow is, as Nabil was pointing out, local and manually refreshes, we've selected an area which we thought was interesting to demonstrate. Ideally, we want this process to be automated, but within the scope of the DSPG project, we didn't have the time to do that. The features are all available here, and we'll have Corey start out with, well, actually, we'll have Sonika start out with explaining some of this rotation information and how interactive it can be. Please, Seneca.
Okay, so there we go. So here is an example of crop rotation, and the users can select any crop that they like. So let's say like cucumbers, then the example 1 pulls up, and here information about the cover crop and termination, all of that also pulls up. We have an option to select examples to just get a general and brief idea of just the information about how crop rotations work and what these examples are. Moving on, here is the specialty crop data set that I was working on. So here we can see all of the information in detail, all the 19 crops, and just, yeah, all the information and the data that we have for all these crops. Yep.
Corey can show the soil section now. Oh, no.
Okay, sorry. So this is the soil dashboard. On the left here, you can select a crop that you want to grow. And then on the right, they have information relating to that crop and then a specific map unit. So let's say we want to look at a specific map unit like this one. It's going to update and give you that information that we talked about for that specific map unit. As you see here, there looks like there's a piece of land that doesn't show. And the reason for that being is it's a river, and I'm no expert at farming, but I don't believe you can grow crops on water. So it just won't show as anything because you can't have any suitability there. And then as you see on the bottom, the lighter color things would be less suitable to grow, whereas the darker color is going to be more suitable. And as you go over and highlight, it's going to show you the number of issues that this piece of land is going to have and tell you why those issues occur. So for this one, the soil texture does not match. This soil looks like it's more susceptible to erosion. This soil's organic matter might be an issue, and that the topsoil looks like it could have been depleted. If we wanted more, you can select that and see that correct information. And then when you select a different crop, the color is going to update to match that crop within itself.
Yep. Nabil, you can now share your weather information. Sorry, I have to, it's weird, I have to approve. Okay. It would help if you weren't muted.
Yeah, so for weather, we'll show you the precipitation on left and then the temperatures. So you can select the years that you want to look at, and it will change and show you the different temperatures and precipitation. But if you wanted to see an average of the years, you can select all, and it will show you the changes for that particular area. As for the risk links, it will update to the location that we have. So right now it is in Wisconsin. And if you wanted to, you can also go directly to the websites from these links. And okay, but yeah, if it doesn't show up here, you can actually go directly to the website and look at the resources that we have. Thank you.
And finally, we have a section on GDD.
Great. Okay, I'll talk about growing degree days then. So what we show there is the image that Sonica showed earlier about your aggregate growing degree days over the year on the top side, and on the bottom side is that same information just shown in a different format. The reason for this value is that because our current month is August, so your high and low temperatures are going to be a little off for that. But on the right side, you can also see a little bit of information about what a growing degree is, as well as some links to provide more information regarding growing degree days.
So this is our dashboard currently.
Do
as
you
we
want to
talk-
try refreshing it? Great.
Yeah, sure. I do.
As you see,
Yeah.
the local host finally went through after all that explanation. So this is now that location that we chose in that earlier demo. So as you can see, if you go to risk links, right? Or if I'm still doing this,
Yeah.
and we go to that drought monitor, we are now in Iowa instead of Wisconsin. So showing you that user input does work. It just takes a little time as of our current process.
So this is our dashboard. If you have any questions about some of the interactive elements, you're welcome to check the page yourself. I've just sent the link in the chat. But for the purposes of our demonstration, that's all we have. We're looking forward to your comments and questions. Thank you. I will just say the automation progress, the automation process takes quite a bit of time. It's
I have a general comment. I think the level of teamwork demonstrated on this project looks to be really, really high. So I really applaud that.
Thank you. They did work to, well, no one here was an expert on horticulture or soil or weather information. So it took a lot of experimenting and talking to one another to fit the pieces together.
Could I ask a
Hey guys,
question
this looks
about your
really
Sergo
good.
data?
Do we get two at the same time? Sorry.
Yeah, I think we just did.
Go ahead, Jay.
I had a question about your Sergo soils data. Is that living actively on a local database, or is that a CSV file, or how are you accessing that data on a small scale locally?
Corey, you want
Yes,
to-
that is a great question. So when we call that function, it downloads the data as a raw file, as a zip file, and stores it in a folder. And basically, anytime you call that file, if that location is a new location, it'll re-download new raw data. But if it's that same location, it'll access that. And then there's also another folder, which is the extractions folder. And there's only like one live data set at a time. So basically, when you call that, it checks to see if it's in that raw folder first. And if it's not, it will download it, but then it will set whatever's in that extractions to that raw folder, if that makes sense.
So they are saved locally currently, and they're called through an API. Yeah.
Is that a part of the delay when you run that process?
Yes.
Is the grabbing the new data from an off-premises server?
Yes, using it because we're downloading from off-premise server, it ranges anywhere from like a minute to a minute and a half, depending on the size of things, as well as I'll speak, the timing of the weather data is about 6 seconds per year of data collected. So it's roughly about 30 to 45 seconds, hence about 2 to 2.5 minutes to just download all the data.
Thank you.
Hey, Corey, that process though, is that the server that's running the PHP? Which server is that? Which server is being used?
It's, to my knowledge, it's locally what's running it is my computer. I couldn't give you a great answer.
So
on
it
that.
is running. Okay, you know what, that's actually the answer I want to hear. So it's running the PHP off of your computer right now. We throw that onto a high performance machine at the university. We should be able to expect substantially
Yes.
faster connections and some processing. So really, that's really good. To have those results at this point actually is really good. Overall, I'm very impressed, you guys. Well, I'm impressed with everybody's stuff today, but with this team, you guys took a fairly obscure project and you've brought it together to help put together the vision that was necessary to help share this project now, to start to get some interest into it, and hopefully we can take it to the next step. So great.
Hi, everyone. I'm just going to echo what Chris said there. I work with Krista in the small farms office here. This was all just an idea in our head. So it was really exciting to see what you guys put together. And we thought you did a really great job. Krista did leave me with a few questions, and we are not programming experts, so hopefully they'll be the easiest questions you have all day. One of our first questions kind of relates to that delay on the Tableau. Totally understand that that's going to happen. Our only question there is, does it show a notice that your report is being generated, or do you just sit on that same screen there? Is there the opportunity for that to be shown so that people are ensured that it is running?
I am not the best at HTML or JavaScript, I will say, but I believe there is an option to show
There is.
that.
Okay.
There is an option. The biggest, I think, impediment right now is all of the files, as Corey was saying, are being generated and working locally. So
Yep.
if this was all in one server or connected servers, that information would be more smooth, and we wouldn't have the. I mean, one of our concerns was we download the data, but as we're downloading, we finish the presentation. Are we going to be able to show that place in time? But it can be done.
Okay.
Yeah, and none of us are full-blown web designers, so we kind of went with, let's get the functionality before the beauty of it.
And I'll just add that these are all next steps. We feel
Yep.
for once we get more funding potentially. So
Yeah, another question that we have, kind of as next steps, Bailey, how hard going forward is it to add more additional crop information in there? Obviously started with a smaller compilation of crops, but there are a lot of specialty crops out there. How hard is that information to add in?
Sonika, do you want to answer that one, maybe?
Well, I'm pretty sure that, well, yeah, I mean, you could always add in more crops. So again, I'm not an expert. So these were the more easily available or accessible kind of information that I found in. And again, 20 is a very short number. So I'm pretty sure that it's not going to be very difficult to do more data scraping and searching for more information. But these were the ones that were just like easily accessible, I would say. So yeah.
especially if we have sources like the two sources Sonica started with, if there was crops that are more like suitable for the southeast part of the US or something, if there's a vegetable guide for those are all things we could add, but we just need to get those resources.
And I also
It's
know,
all like the egg mark reports though. What we found, so they went after kind of the easy data to access. We know that some of that other data gets exponentially harder to get and bring in, but the system looks like it's designed to bring it in. It's just a matter of having the ability to access it and find it.
and I know just maybe not even adding crops, but maybe adding more information to existing crops is easy once you have the data, but I also know obtaining some of the data is hard, because some of the things that we have for corn and like oats is done experimentally, and there's been a bunch of experiments done with corn, but there haven't been as many experiments and data postings for the specialty crops. So that's a lot where a lot of the challenges come into it as
Yeah.
well.
Our choice of using those crops was also dependent on some of the yearly rotations that we wanted to show. We don't know how to tell farmers to work, multi-year processes on their land. So with these crops, we do, because the experts have done it. We just kind of pull that information. So I think the answer is maybe you have to hire Sonika, and she can do it.
Yeah, I really liked to see that crop rotation part in there, you guys. That was really good, and the cover crop information in there too. I will tell you, on the horticulture side of things, we run into not having enough information on some of these specialty crops. So we totally understand that. Just curious kind of if we could provide that information, if that could be done. My last question, and also I think hopefully easy, it looked like you guys already answered it for me. Krista was curious about how easy it would be to utilize this in surrounding states. It looks like most of those databases are national, but as for like the crop databases, would that be something that would be different in various states? How hard would that be to apply across borders?
I can add for maybe the crop part of it. So before we looked at the Midwest Vegetable Guide for the Midwest region. We also had one on the North Atlantic region. And so some of the pH levels and some of the recommendations on the soil type, etc., that information I think needs to be changed a little bit, because we focus largely on this. The crop information doesn't necessarily have to change. So it's just a matter of the system having to recognize where the soil is. Corey, do you want to add to that?
And to answer that, the Sergo, as we mentioned, covers about 95% of the US.
Okay.
It might be a little outdated, and I know you guys will recommend to get a own soil test of your own, but as long as it's a place that the Sergo has taken data over, it should be fine. And I know the Mesonet will take from any lat long as it's a valid location. So I don't see any major initial issues with trying to pick outside a location. And that's why we try to show a region outside of Iowa in Wisconsin.
Perfect. Well, thank you all very much. It was, like I said, really exciting to see. Hopefully I can walk Krista through this dashboard once she gets off her meeting with Jay, and she will be equally as excited, I am sure. So thank you very much.
Thank you for your interesting questions.